2 of VFD drive installation, wiring, and testing. Now the actual wire bundle in here, some of this is going to change, but I can deal with that after. Right now, because I just want to get the conduit up in here, and we'll deal with the wiring changes after this. So I'm getting a little further on the wiring here. Starting to get my terminal blocks all done here. At least the left one. The left one is the power one. The right one is probably going to be signal stuff, and I'm not sure exactly how that's all going to go just yet. It's for, you know, like start, stop buttons, all that. But the important one is this one on the left that handles all the power. So these red lines are signal lines that come from the control box up here, and some of that may change. I'm not fully decided on that yet, but these lines go up to the inverter. So these ones on the left go to the motor side of it, and the ones on the right go to the power. We jump over, and there's going to be another 6 that come off these right-hand 6 terminals, which will be motor and power going out this way for the horizontal spindle motor, which is down here in the base, and that's the big one. So right now I got to make up the next set of wires that go on here, just crimping some terminals. So here we're working on those wires, and I've already got a start on this. That's one that's been done on that end. I still got to strip the other end. These 2 ready for terminals on the one end. So this is the tool, and it's an older style. It just does a zigzag. The back ones hold it, and then you got one little spike goes up and crimps it in. And there's a couple different spots there for different size terminals for different gauge wires. So this is gauge 10 wire. It's pretty heavy stuff, so I'm using the big one on the back. So I look for this little ridge on here, and I just space out so that I leave that much insulation goes in. So I just use my thumb as a stop, and I place the head of the wire, the insulation, right at the shoulder. So when I insert it, I know that that's going to the end of that shoulder and is in the metal crimp part here. A little off angle on that. And where this is heavy gauge, I got to really put some pressure on it. And here I usually just flatten this down a little bit just to neaten it up. It's not critical, but I like to do it. So that's the end. This one's a little longer than it should be, but it's acceptable. So that does that end, and now I got to strip the other end off. And these don't get any terminals. The way they're set up on the VFD drives, they just go underneath like a square cap under there. So I got to check my depth on what that should be, and I'll be right back. With the soft insulation, you can usually just cut one spot and pull it off, but this is pretty tough stuff, so I usually do 3 spots in the same ring. I just kind of rotate it in the groove, give it another cut. and then it comes off nice and clean. And if you haven't used these, they get a hole where the wire goes through, so you don't cut the wire itself. There's different kinds. There's some that literally pull the cover off as you squeeze it, but I found they don't typically work as good. These are my favorite type, but to each their own on what type they like to use if you do enough of this. So I got these are for the, let's see, these are for the motor side. They're a little longer. I got to do some shorter ones that will be for the power side. Now I've got two different types of terminals here. I've got ring terminals, and I've got the spades, and I use them in different applications. The terminals that are part of the machine that pretty much stay in place, and that there should never be removed, or very rarely. It would have to be something pretty serious to have to undo these or use these, because these are more secure. But on the inverters or VFD drives, I'm using spades where these connect to the terminal bar there, because they're easier to get in and out in a tight space. And you know, the VFD drive, there's possibility of failure. It's a fairly complicated electronic device. They are known to fail on occasion. So I'm doing these with something that's a little easier to change it out if I need to, so I don't have to fight with taking the screw all the way out and trying to fit everything up, especially when I have overlapping terminals in there. With this, I have everything that goes to the VFD drives. I've got on a separate screw on there that doesn't have anything else loaded on it. I'll show you later, but the way that terminal bar goes is it's strips that have two screws on each strip. So each one is a connection that goes through from all the wires connected to it. So all the permanent stuff I put on the upper screws, and then the VFD drives are connected to the lower screws where I can access it. So all I have to do on those is just loosen the screw a little bit, pull this out, and then I can change it, put it back in, tighten the screw up. Try to get you in so you can actually see a little bit. Sorry, it's not the best light. It's about the best I can get it in here, though. So, because it's so tight to the bottom here, the bottom of the VFD drives is right about there. So it is cramped, very cramped quarters in here. So a lot of what I'm having to do here is bend the top of the terminals over to have enough room. Otherwise they'd be coming all the way up into here, which would be too far up. Normally these terminals, you go one up and one down like that, but obviously I don't have room to go down, so I'm layering them is what I'm doing. So I've got that angle on there, and then I'll slip it in and screw it down. Okay, so that's our three long ones, and that's the motor side. And now I'm going to do the three shorter ones that will be for the power. It's a little hard to see here, but the first two here are the hot lines from the 220 coming in. Now this comes in at single phase 220 coming in at 220 or 240 volts. And the third line is a neutral / ground line. So the inverters just have, they reference the ground. They probably ground just to keep the your control stuff at a low potential. I'm not sure exactly how they do, if that's done or not, but there is a ground reference in there. Then from here I've got these two power lines on the ground. They jump over 3 terminals over and do the same thing here, and these go up to the other inverter for the power. And I've also, if you can see these two lines here, this white and green, and this red line that comes up to the fuse over here, that's for the outlet that's down below here. So I'm just taking one side of the 220 and reference the ground / neutral, it does the outlet. And I've got this disconnected here, but that goes over to the outlet for the output. So that would be the hot line on it. Now a lot of these components, the terminal blocks and the fuse, this is repurposed from the old equipment that was in the machine when I bought it. Okay, so this is the hot line to the outlet, and I got to figure out what's going to be my best route over there that's not going to interfere with a bunch of stuff. Yes, I didn't like going through the other wires. The ends were too close. The potential for a short if one of these cracks or anything. I really don't like relying on the insulation of these, because I've seen them fail too many times. So I think this routing will work pretty good. I just had to do a crimp in it like I've done on a lot of the lower ones. And that keeps a good spacing away. So even if the insulation cracks, they're not going to touch. So the red control wires for now, till I figure this out, I think I'm just going to tape them up and tuck them away, and I'm going to get the inverters in next, because I do want to get this up and running and just work it manual from the control panel I built here, and at a later date I'll work through the logic and figure out how I'm going to do all that, and we'll finish that up at a later date. So I forgot I had an extra ground line coming up here because I replaced the original one, which was 12 gauge, with a 10 gauge coming up to match the power wire coming up as well. So instead of using this blue tape, I'm going to redo these. I took that extra green line that was 12 gauge, and I made 2 short leads to go up to the VFD drive, so I'm going to replace these. The green is conventional for ground, which is what I was using the blue tape to indicate. I think the bottom ones are going to be a real challenge to get at. Okay, so I got all the wiring for the power set up. I'll give a little demonstration here. You can see the controls are lit up here, so you can get it to focus. Come on, focus. So, take a look in here. So I'm still going to put my covers on here, but we got our power wiring is done. Everything seems to be functional. The VFD drives are actually running right now. Got the power fan on the back there is going, and our outlet is hooked up, which is powering that fan and also powering the DRO up here. I still have to do my scales for the DRO, but at least we got power here to start. Okay, so let me close this and we'll run this a little bit. Okay, so I gotta start the knee motor first. I also put this bracket in on the bottom here for my connections in the lower cabinet. That wasn't there before. Okay, so we'll start up the vertical spindle first, the overarm. Okay, so that's running good, and if you can see this, yeah, let me zoom in. So that's reading the current draw for the motor, and we're looking at the left one here, which is the overarm. The one on the right is for the horizontal. So we'll shut this, and we'll start up the motor for the horizontal. So this is much quieter. The knee motor is noisy, but the motor for the horizontal is very quiet. Doesn't make much noise at all. So I've got the horizontal is also set to 2000 RPM, and this one works with a clutch. It's not a direct drive like the overarm. So we're going to pull this in slowly, and we're up and running. And if you look up here, we got our current draw for the horizontal. Because this is no load, so the amperage is kind of low on this. This is a 7.5 horsepower motor for the horizontal, so it does draw quite a bit when it's under full load. RO's powered up. So I think that pretty well wraps this up for today. It's early morning now, so I gotta pack it in, get some sleep at this point. So today, actually I started cut last night, but working a little further on this, I'm starting to wire up the controls for the inverters. The bottom ones are all done, or the bottom one, but these top two need to get set up. I had it working on the front control here, but what I'm working on now is they're going to be controlled from this box here, and part of this involved, because the inverters work a little different than the machine originally did, I've had to rewire a little bit of this so that the inverters can make sense of the controls. This switch, I wish I had another junction on here, or another switch on this stack, because the way the switching on this inverter works, it isn't quite compatible with this, though I think I can fake it, because it switches with, how do I put it, you've got a momentary run button, and then you have a reverse button to run it in the opposite direction, and this one is going to be for the spindle, so I do want that reverse. But it isn't like just a forward and reverse. You have to hold the run button, and in order to get it to run reverse, you have to do both run and the reverse button at the same time, and they're both momentary. Now I've done a little testing, and it's DC 24 volts on the signaling on the inverter here. I've gone in here with the multimeter and just see how it works. So I'm pretty sure that what I can do is use a diode on this, because I mean, you can't just jump her from one to the other, because then it's always going to run in reverse. But if I do a diode across, and the way this stack works on here is, if you're in one position, it will connect across from the bottom to the bottom, and if it's in the opposite position, it will run top to top, and the bottom one shuts off. It just reverses when you go left or right. In the middle, both of them are off. So what I'll do is I'll run a diode from one to the other, and I'll have to check the polarity to make sure I get that right. But that'll allow it so when I'm on, say I use the bottom one as run only, or forward, when the bottom one is connected, it'll just go out and it'll run forward. And when I put it in reverse, I'll hook that up to the reversing switch, and the diode will also turn on the run as well. But it prevents it from backing up, that if I just have it in run, that it doesn't feed power to the reverse. And that lets you, well, should let me get them independent of each other. So that's what the plan there is. I don't know if I have one in stock right now. I may have to order that. I think I've got them somewhere in my basement, so I'll dig for that later. But for now, I'm going to go through the testing, get this wired up as far as I can go. I think everything in here I can close up here, and I'll probably do the diode right on the terminals right down in here. I'll just do a loop and back up. It'd be easier to maintain than opening that box. So now I gotta go through all which each terminal is and trace these out. I believe these still have numbers on them, so I should be able to follow that, get it all hooked up. And one of the complications here that makes this a little more, well, they get pretty complicated to begin with, but I've got 3 different inverters here, and each one has different programming. Now, these two are the same brand, but they're different series, and the feature set is different, so that the whole set of code is completely different. Now, this one is a fairly inexpensive inverter. It doesn't have a lot of features, which makes it easier to hook up, but you don't have as much flexibility with it. These two have a lot more features, and typically they go up. The better inverter it is, the more features you have, but it also makes it more complicated. Now this one, it literally has like a couple of hundred different settings on it. But here's a little clue. Okay, this one is the 7.5, which is the one that's in the book for. And these are all settings that I've had to do to get this configured. So that was my list that I went through, and when I studied through the book, see what I had to change on this. And on the other side of this paper, this is the one for the 4 kilowatt inverter, the one in the middle here. So all these had to be programmed in. Now this one here, I didn't write up a list on it, and I had already programmed that earlier on. I'm not doing any special stuff with that, so it was pretty basic on that one. I don't know if this will show up, but this is one of the diagrams that they show. Well, it's the main diagram for all the hookups on it. So it just shows you what's what. Try to do this one-handed here. So you've got these are the connection terminals for your all your controls, basically button type controls. Or sensors or anything like that. This here is if you do an external speed control, which I'm not using that at present. I thought about it, but I don't think I really need it. Most of the time I'm going to run this stock speed, and if I have to change the speed, I can control it still from the control panels up here. So it's not really necessary for me to do a remote one. Let's see, not that one. Over here we have a relay output, which I'm going to use this to control the feed on the machine. Basically, as a safety feature, it will automatically stop the feed if the motor is not turning at its rated speed. That'll prevent jams. If I'm cutting and for some reason it gets overloaded, or I forget to engage the motor, or I forget to disengage the feed and start things up without the spindle going, it'll prevent a jam because the feed won't feed until everything is up to speed. So up here we have our input on the power, so that would be our 220 coming in, and this is the power going out to the motor, which is 3-phase, so you have 3 lines there. And there's some additional stuff here that can be used to like feed meters and stuff. You know, if you want an external meter that shows the amperage you're drawing, something like that, it enables you to do that. So just a little clue as to what's all in one of these things. Now you don't have to use all these features. You can run them actually just as a straight box and run it off the control panel alone. But they're here for doing more advanced setups like what I'm doing here. And this is actually capable of a lot more even than what I'm doing. But I don't need to go that far. I don't have the needs for those additional features. So I'm getting very close to done with the wiring here. I've got my controls are in on both of them for start, stop. One of these is a common wire. And then I've got e-stop on it, the emergency stop. The only thing I have left is there are relays in here that are going to control the feed solenoid. That's going to go to these 2 lines here that go down to the bottom. That's my next step. I have to wire them. And I still need to get that diode. I looked for it in the basement. I don't have one on hand, so I'll have to order that. I'll be able to use it in the meantime because most of what I do I'm going to be using forward anyways, which that will work without it. I just need the diode to activate reverse. And I can install it at a later date without having to take everything apart. I can just take the lower cover off this and do a jumper, and that's pretty much the end of it. Well, I ran into a little snag here. Nothing that can't be solved, but on the relay solenoid, the lines that come up from here, so I was going to use the relay on both of these so that if either one is in the run position and ready to engage the solenoid, they both have the capability of engaging it. So the plan was to run the solenoid up to this one, which the contact strip on here is a little bit bigger than the one on this side, the openings on them. And I was going to double up the wires on this side, run up to here, and then come back to the other one. But it turns out they're not big enough to fit two wires under there. I can barely get the one under it. So what I've ended up having to do here is I had to drill and tap and install another terminal block over here. So I'm going to run the solenoid lines to one side of this, and then I'll run a line off to each of the inverters from the other contacts. And that should take care of that. Just a little diversion I had to deal with. Okay, so I'm about ready to wrap up for today. I think I've accomplished quite a bit here. I want to show you a little bit of where I'm currently at. This is pretty much at a usable state right now. A few little things I have to finish, basically to do with the emergency stop switch. Everything else seems to be working good, so I'm going to start this up. We're going to start the knee motor. I've got that set up on this switch here. The bottom one is a reset button in case the inverter faults, which it shouldn't on this. You can run into it on the spindles if you overload them, but the knee motor shouldn't fault. It's going to be a little loud. So now I can start my spindles. I'm going to start. I've got the horizontal is just on off using the start and stop button. That's it. Oh, I'm still at fault for testing. Okay, so we're going to start horizontal. Okay, and it's running, and once I engage the clutch, we've got engagement, and it's spent. So the horizontal is running, and we can stop. In fact, I'll leave it engaged so you can see this. It takes 4 seconds to wind down, 2 seconds to start up. Okay, so that's our horizontal hooked up here. And now I've got the vertical spindle is on this, and I've got left and right. I still need to get the left set up. I'm going to need to get that dialed. I have to order it, but the right side is working. And we turn it to off, and it goes back off. So the next thing that I did on here is I have my the feed is set up to work with the spindle motors, so I can use the quick feeds or the rapids at any point, as long as the knee motor is running. The spindles don't have to be turning for that. But as far as the feeds go, just pulling in the clutch, nothing happens with the feeds until I start the spindle, and it has to reach full speed. I've got it set it fast enough that you should be able to see it here. this will actually automatically start and stop. And what it does is it waits until the motor gets to full speed. And as soon as the motor slows down more than about 5%, it'll stop the table. And part of the reason for that is if the motor gets overloaded, it'll prevent it from jamming into the end mill, or if you're using a horizontal cutter, it'll prevent it from running into it and without it turning and jamming things up. So I'm going to start the spindle again, and you should see the table move now. And there's the engagement. And as soon as I stop this and it starts to slow down, table stops. And the same is true with the horizontal. So now the horizontal is going, the table is moving again. And if I hit stop, the table stops. So I think that pretty well completes it for now. Let me shut the noise, man. I think that pretty well completes it for now. I've got those few little things left, but I'm pretty happy with where I'm at for the moment. I'm actually usable at this point again, and the way that I want to have it when I use it. You've got the original control up here. Though this is configured a little different than what it was. This originally did not do the horizontal, the start and stop up here. These originally used to set it for left or right and then hit start for the overarm and stop for the overarm. And the horizontal spindle actually worked from down here. You had to turn it on from these switches. But I decided when I did this, I wanted it all up here. I like this setup better, especially where I've got the automatic table on it, the feed on it. So my diodes came in, and I just installed this, this right here. So this allows me to get reverse. So here it is. See if I can get this all in one shot here. Got the spindle there, and we'll go forward, which is the normal. And we'll go off. And now we're going to go to the left here, reverse. And that is working just exactly the way I want it to. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.